$128 billion. That's what California has spent on a train that has never carried a single passenger. Voters approved it in 2008. Construction started in 2015. It's 2026. The tracks end in a field outside Fresno. No station, no platform, no trains. The original promise was straightforward. Connect Los Angeles to San Francisco in 2 hours 40 minutes. 800 kilometers of dedicated high-speed track. Trains running at 350 kilometers per hour. A system that would carry 117,000 passengers per day by 2035. Total cost, $33 billion. Completion, 2020. California would join Japan, France, Spain, China, the countries that had already built this technology and proved it works. In November 2008, 52.7% of California voters approved Proposition 1A, $9.95 billion in general obligation bonds. The federal government added $3.5 billion under the 2009 American Recovery and Reinvestment Act. Shovels would hit dirt within the year. The Central Valley first. Flat farmland between Merced and Bakersfield, the easiest 274 kilometers of the 800-kilometer route. Build the spine, then extend north through the Pacheco Pass to San Jose and San Francisco. Then south through the Tehachapi Mountains to Los Angeles. 3 phases, 1 system, done by 2020. That was the plan. Workers break ground in Fresno on January 6, 2015, 7 years after the vote. The gap between approval and construction tells its own story. Environmental reviews, property lawsuits, route disputes, federal conditions requiring the Central Valley segment to begin before any urban section. 7 years of preparation before a single pile enters the ground. But now the work begins. Workers drive steel H-piles into the valley floor. Pile drivers hammer 24-meter shafts through layers of clay, sand, and silty loam. The Central Valley sits on alluvial deposits, material carried down from the Sierra Nevada over millions of years, compacted but not uniform. Workers probe each zone before committing to a foundation design. What the geotechnical models predicted and what the drill encounters are not always the same thing. Concrete crews pour footings for elevated viaducts. The guideway will run above grade through much of the valley, above flood zones, above farm roads, above the irrigation channels that cross the agricultural land every few hundred meters. The design calls for precast concrete box girders, each one 3.4 meters deep, post-tensioned with high-strength steel cables. Workers position the segments with launching gantries that roll along the completed portion of the viaduct and reach forward to place each new span. Each girder weighs between 600 and 900 tons, depending on span length. Workers weld rebar cages for pier columns. Each column poured in a single continuous operation. No cold joints, no interruptions. The concrete mix is specified for durability. Low water-cement ratio, silica fume additive, designed to last 100 years without major maintenance. Workers calibrate the formwork to within 5 millimeters of the design alignment. The curves on a 350 kilometers per hour railway are gentle, radius of 7,000 meters or more. But the cant, the banking of the track, must be precise to the millimeter. The first construction package covers 29 kilometers between Avenue 17 and East American Avenue in Fresno County. 36 separate structures. The Fresno River Viaduct, 388 meters long, 14 spans, 13 meters above the river at its highest point. The San Joaquin River Crossing, a concrete bridge 440 meters long over one of the valley's major waterways. Road overcrossings at every county route, every state highway. Workers build them one by one through 2016, 2017, 2018. From a satellite, the alignment is visible. a white line of concrete structures threading south through green and brown fields. Workers are on site 6 days a week. Concrete trucks queue at batch plants set up at the edge of active zones. Crane operators swing girder segments into position in the early morning, before the Central Valley heat peaks above 40 degrees Celsius. By midday, workers move to shaded tasks: rebar tying, form stripping, joint sealing. Here is how the full system was designed to work. The tracks are dedicated. No freight, no slow regional trains, no shared right-of-way. This is the foundational requirement for high-speed rail. The moment a high-speed train shares track with slower traffic, the schedule collapses. California's plan called for fully grade-separated infrastructure from Los Angeles to San Francisco. Every road crossing a bridge or an underpass. No level crossings, no traffic lights, no stops except designated stations. Power comes from a 25 kilovolt alternating current overhead catenary system. Pantographs on the roof of each train set press against the wire and draw current continuously at speed. The system is the same standard used in France, Spain, Japan, and China. Off-the-shelf technology, proven at scale. The train sets themselves, never ordered but specified in the authority's rolling stock plan, would be electric multiple units, every axle powered. Distributed traction, not a single locomotive. This spreads the weight across the train and allows faster acceleration and braking. A train set accelerates from 0 to 350 kilometers per hour in under 4 minutes. It brakes from 350 kilometers per hour to a full stop in 4.5 kilometers. At station stops, dwell time is 2 minutes, then back to full speed. At 350 kilometers per hour, the train covers 1 kilometer every 10.3 seconds. Los Angeles Union Station to San Francisco Transbay Terminal, 2 hours 40 minutes. The same journey by car, 5 to 7 hours depending on traffic. By the existing Amtrak Coast Starlight, 9 to 12 hours. The time saving is the product. That is what 117,000 passengers per day would be paying for. The technology is not experimental. Japan's Tokaido Shinkansen opened in 1964. It runs 515 kilometers from Tokyo to Osaka. 170 million passengers per year. Average delay across all services, 54 seconds. 0 passenger fatalities in 62 years of operation. France's TGV began service in 1981. Spain's AVE network now covers 3,400 kilometers. China constructed 38,000 kilometers of high-speed rail between 2008 and 2023, the largest infrastructure program in human history. Every one of these systems runs on the same principles California planned to use: dedicated track, electric traction, grade separation, precise civil engineering. California's version started braking before the trains were ever specified. The geology under the Central Valley is more complicated than the original surveys suggested. Workers hit groundwater at 3 meters below grade in sections near the Kings River. The water table across parts of the valley is shallow and variable, affected by decades of agricultural irrigation and groundwater pumping that has caused measurable land subsidence. In some zones, the ground is sinking at 30 centimeters per year. A railway designed to millimeter tolerances cannot sit on a foundation that moves. Liquefaction risk zones required redesigned foundations. A pier that the original bid assumed would need a 12-meter pile now requires a 28-meter pile, then a 34-meter pile after additional soil testing. The contractor submits a change order. The authority reviews it. The review takes 4 months. The change order is approved. Workers mobilize the larger equipment. The schedule slips. Then, the land acquisition. California's eminent domain process requires individual condemnation proceedings for each parcel. The Central Valley route crosses 1,400 separate properties on the first 274 kilometers. Farms, dairies, equipment yards. Family homes that have been on the same land for 3 generations. The authority must appraise each parcel, make an offer, negotiate, and if the owner contests the valuation, go to court. Some cases settle in 6 months. Some take 4 years. One dairy operation near Hanford, Kings County, held up a 5-kilometer section of alignment for 31 months. The farm's irrigation infrastructure crossed the right-of-way in 7 places. Each crossing required a separate agreement on relocation, replacement, and compensation. Workers waited. The gantry crane sat idle on the completed section to the north. Then the biological surveys. The Central Valley is habitat for 23 federally or state-listed species: the San Joaquin kit fox, the blunt-nosed leopard lizard, the tricolored blackbird, the giant garter snake, the California tiger salamander. Each species required pre-construction surveys across the entire alignment. Seasonal construction windows. No ground disturbance during breeding seasons. For certain species, that meant no work between February and August. Workers on those sections moved to non-restricted tasks or shifted to other segments. The construction season in some zones was effectively 4 months per year. The cost began to move in 2011. The first comprehensive revision, $43 billion, up 30% from the 2008 estimate. The authority cited right-of-way costs, updated environmental requirements, and refined engineering. In 2012, a peer review panel, the independent peer review group mandated by Proposition 1A, released its assessment. The $43 billion figure was not credible. The panel estimated the true cost at $53 to $68 billion. The authority published a revised plan in 2012, $68 billion. Completion date pushed to 2029. In 2018, $77 billion. Completion 2033. In 2022, $105 billion. In 2024, $128 billion. Completion date for the full system, undefined. The authority no longer publishes a date for Los Angeles to San Francisco service. Each revision followed the same pattern. New cost estimates came in higher than the previous model. New environmental conditions added scope. New right-of-way disputes added time. New engineering challenges added cost. The project did not experience one large failure. It experienced continuous, compounding cost growth across every category simultaneously. Where did $128 billion come from? The 2024 program budget breaks it down. Right-of-way acquisition, $5.7 billion, 300% over the 2008 estimate. Environmental mitigation and permitting, $3.2 billion. Civil construction contracts, $28.4 billion for the Central Valley segment alone, with average overruns of 31% per contract package. Program management, oversight, and administration, $4.1 billion over the life of the program. Legal costs, $780 million through 2024. Financing costs, interest on the bonds, accumulating at $600 million per year. The federal $3.5 billion came with a condition. It had to be spent by 2017 or returned. California spent it on the Central Valley, the segment with the fewest passengers and the furthest distance from either major city. The money is gone. The segment is incomplete. Workers on the active construction packages work Monday through Saturday. Concrete batch plants run from 5 a.m. Iron workers tie rebar in temperatures that reach 43 degrees Celsius by early afternoon. Crane operators in air-conditioned cabs lift girder segments into position. Surveyors check alignment after every pour. Workers run quality control checklists, concrete cylinder tests, rebar cover measurements, torque checks on post-tensioning anchors. Some of these workers have been on the project for 9 years. They have worked under 3 chief executives of the Rail Authority. 2 governors, 5 project managers on their specific construction package. They have watched the scope change 4 times, segments added, removed, redesigned. They pour concrete into forms that have been modified from the original drawings. They build structures whose connection to the next structure remains uncontracted. The segment south of Bakersfield does not exist on paper as a funded project. The Tehachapi crossing requires 36 kilometers of tunnels and a mountain crossing through one of the most seismically active regions in North America. The alignment crosses the Garlock Fault, a major strike-slip fault capable of magnitude 7.8 earthquakes, and approaches the San Andreas Fault Zone. Tunnel boring through this terrain requires a machine capable of operating in squeezing ground, mixed face conditions, and fault gouge. Rock temperatures at depth exceed 55 degrees Celsius. No tunnel boring machine has been ordered. No contractor has been selected. The cost estimate for this section, $35 billion. That estimate was produced in 2022. It has not been updated. North of Merced, the Pacheco Pass crossing requires 22 kilometers of tunnels under the Diablo Range. The geology there is serpentinite and Franciscan mélange, chaotic, sheared rock with no predictable structure. The same rock type caused the most expensive tunneling overruns in the history of the Boston Big Dig. No contractor has been selected, no boring machine ordered. Cost estimate, $18 billion. The Central Valley segment, the piece actually under construction, connects Merced to Bakersfield. Merced, population 86,000. Bakersfield, population 410,000. Combined metro area, 1.1 million people. No direct connection to Los Angeles. No direct connection to San Francisco. When the Central Valley segment opens, if it opens by 2030, passengers would board the train in Merced, ride 274 kilometers south to Bakersfield, and then transfer to a bus to reach Los Angeles. Or they would drive to the nearest Amtrak station and continue by conventional rail. The journey time from San Francisco to Los Angeles via this route, approximately 6 hours. The existing Amtrak San Joaquin service, 7.5 hours. The time saving, 90 minutes. At a capital cost of $128 billion. Japan built the Tokaido Shinkansen, Tokyo to Osaka, 515 kilometers, in 65 months. Construction began in April 1959. First revenue service, October 1, 1964. Total cost in today's dollars, approximately $15 billion. The line turned a profit in its 3rd year of operation. Today, it carries 170 million passengers annually and has never had a fatal accident. California has spent 18 years and $128 billion building 274 kilometers that connects 2 mid-sized valley cities to each other, and nothing else. What stands today along the alignment from Merced to Bakersfield? Drive State Route 99 south from Fresno. The viaduct structures appear on the left and right of the highway. White concrete piers rising 12 meters from the farmland, box girders spanning between them. Some sections are complete. The guideway deck is poured. The parapet walls are finished. The surface is smooth. No rail. No catenary poles. No overhead wire. The surface is bare concrete, open to the sky. Birds nest on the bearing pads between girder and pier cap. Other sections are still in formwork. The wooden forms cling to the sides of columns mid-pour. Rebar extends from the tops of partially completed piers, waiting for the next lift. Construction fencing lines the right-of-way. No workers visible on a Tuesday afternoon. The gate is padlocked. The Fresno station site is a surface parking lot adjacent to the existing Amtrak station on Tulare Street. The authority owns the land. No construction has begun. The architectural renderings show a glass and steel canopy over 2 island platforms. The parking lot shows parked cars and a chain-link fence. Bakersfield Station, A cleared lot at the intersection of F Street and Golden State Avenue. Graded flat. A construction hoarding fence around the perimeter. One sign, California High-Speed Rail, Bakersfield Station. Behind the fence, a concrete slab, a foundation for a temporary construction office since removed. Nothing else. Kings/Tulare Regional Station near Hanford. A field. The authority designated this site to anchor a new transit-oriented development, 50,000 residents within walking distance of the station, reducing car dependency in the valley's fastest-growing region. The site is agricultural land. No grading, no fencing. A small brown sign at the road edge, half obscured by grass. The rolling stock has not been ordered. The authority issued a request for expressions of interest from train manufacturers in 2019. Responses came from Alstom, Siemens, Hitachi, and CAF. No contract was awarded. The procurement was suspended pending resolution of the route alignment. It has not been restarted. The signaling and train control system, the software and hardware that allows trains to run safely at 350 kilometers per hour with 2-minute headways, has not been designed. No contractor selected. No specification published. The overhead catenary system, the 25 kilovolt wire and the steel poles that support it, has not been contracted for any section of the valley alignment. Workers pour the concrete guideway. The catenary poles will come later. No contract exists for later. Workers finish the afternoon shift. Concrete trucks return to the batch plant. The crane operator lowers the hook and climbs down. The site goes quiet. The viaducts stand in the evening light, complete, empty, carrying nothing. A hawk sits on a pier cap 12 meters above the alfalfa fields. Across the Pacific, Shinkansen N700S train sets depart Tokyo Station every 3 minutes during morning peak. Each train carries 1,323 passengers. The trains run within 54 seconds of schedule on average, across a network of 3,000 kilometers. The Tokaido line alone generates $3 billion in annual profit. The infrastructure paid for itself decades ago. $128 billion. 18 years. 274 kilometers of partially complete guideway. 0 passengers. 0 trains ordered. 0 stations built. 0 catenary wire installed. The mountain crossings unfunded. The cities at both ends unconnected. The cost still climbing. Workers will be back on site Monday morning. Subscribe for more engineering stories.